let's look at the first one. I don't know. Do you have anybody have context on this one? If not, we can assume some context.
So yeah, I asked this question.
Yep.
So the context is I was watching the Netflix and YouTube system design, some of the videos in the YouTube and the Google also. I was searching them in the Google, but what I understood is that they were just going away from like how they will be copying the data, the video as such. Right? That is not being dealt with, right? And the use case for the YouTube and Netflix is the data that is being moved from your system to the server is huge. It's not like a small data, right? I think you're bound to get errors in between while you're loading. And how is the acknowledgement going through, and how is the client going to handle them, right? So all those things I thought may be interesting to discuss.
Yeah. So this is about uploading you're talking about.
Yep.
Yeah.
Oh, okay. So if I understand correctly, I remember I read a Dropbox blog. So you means to say that like if I'm if Anil, if you're a user, you're trying to upload a video from your laptop to the YouTube server of a public viewing, how
Yep.
does that happen? Correct?
Yeah. How does that happen?
Okay.
And because the move of the data is very large, so
Yeah.
generally it's how is it optimized and all those things. Right?
Okay. So I don't know. In a Dropbox engineering blog, there was a explanation how Dropbox does this upload. Like they break that into chunk, and I can share that link if you want. So it shows how they have that something called the sync, right? I forgot the name, like live sync or something. There is a functionality. So they use the I forgot. I read it a couple of months back. I can share the link. But it is from a. I think the idea should be same, maybe different, because there it says like how a big file, how they break it into chunks of like I think 4 MB or something, and then they upload that, and then again they remerge that. I can share the link here actually, but I don't know that's what YouTube does it for big files. I'm not sure.
Yeah. So those are good. I think let's say if we go back to what we were talking about last week, when we look at a problem, what is the business context in this case? What we're saying is that we wanted to be able to upload large files to the cloud, right?
Sorry, Vijay. I'm sorry to cut you. I just want to add one more point in this slide. Can we add AWS S3 also? I think it has the same scenario. We are uploading huge amount of data to AWS S3.
Yep.
One of my friends asked this question. How AWS S3 works for system design.
Yeah.
So can we just add that point also? Because I think everything has the same base.
Yeah. So upload to S3. So it's good that we're bringing up all this stuff because they actually matter. To give you an example, let's say if we were designing, I like to use analogies because analogies, they're closer to our day-to-day life, right? Let's say if you design a data warehouse and a data warehouse, you're storing something. What would be the criteria that you think about when you're designing this warehouse? I can get started a little bit. First, I think for also probably most important in that case will be, what are you going to store? Right? If you're storing, let's say, fresh vegetables versus some non-perishable food, you have to think about, refrigeration and stuff like that.
Yeah.
In this case, it actually matters quite a bit what type of file you're trying to support. Examples of Dropbox and S3, they lean more towards the general purpose storage, right? So it doesn't matter what is the underlying stuff. You just want to be able to upload. Even within that, there is a difference because Dropbox tend to have smaller files. Actually, it doesn't matter. Dropbox and S3 may in that case may have smaller files. So yeah, scratch that. I think that probably doesn't matter that much.
Yeah, and can we assume here that we will not have .exe files?
.txt?
.exe executable files.
Oh, exe. Yeah, I mean exe S3 you can have whatever. So to me, S3 is the lowest level, meaning that it actually doesn't necessarily, it can store pretty much everything. Dropbox, when it stores stuff, it already knows it's a one kind of file. So there's metadata around it. If it's a video, it's a special format of video. So in this case, YouTube and Netflix would come in. So the first thing I think to figure out is type of files supported, right? Give you another example why it matters. For example, Azure also has a blob storage, same thing as S3.
Yeah.
When you upload, let's say a virtual machine image, VHD, right? VHD can be very big, can be 30 gig, can be 50 gig, can be 120 gig. But when you're uploading that, potential optimizations you can do, it turns out, is that when you are uploading those big VHDs, the VHDs, what tend to have is, they actually tend to have a lot of zeros. Because when you have an operating system of, say, a 50 gig, actual data or actual byte that has significance only takes, let's say, 10 gig. The rest of the 40 gig are actually just zeros. So one of the optimizations that was done in Azure was actually to just, it's called page blob. Basically, it's kind of like a streaming, but it's able to essentially reduce the need to upload all the zeros. Because with zeros, all you need to know is, how many zeros are you gonna upload? So that's like reducing from, say, potentially 40 gig to even just 1 byte. So you can do a lot of optimization based on the kind of file that you're uploading. For video file myself, I'm not too familiar with all different kind of format, but normally video file follows streaming format. Basically, you can read from the beginning to the end, and there's offset, basically that's a pointer of where you're reading, and everything basically after that is, just a stream of data. So in that case, when you are uploading bigger files, normally there is the technique called chunking. This is kind of irrelevant of where it goes to S3 or whatever. This matters when you're uploading through HTTP. And then you have to chunk your data into multiple chunks. I think HTTP is native.
Yeah,
So,
and with chunking, we will have codec conversion as well, right?
Sorry?
We will have codecs as codec generation of codecs, like MP4, AVI, and the pixel rate.
Codec,
Codec.
codec, COD.
Yes.
Yes. Okay. Yeah.
So we will need that as well, right?
Yeah. So is it a question, or it's hard to hear?
Yeah, it was question. I'm asking you, do we need that codecs as well? Do we need to consider it or no?
Codecs? My answer will be actually, I don't know, because the video files, like I said, I'm not too familiar. I think like MP4, those kind of stuff are containers of certain file, and then you need the codecs to actually be able to play what there is. So I'm guessing that codecs will be part of this file. Maybe it's like a metadata, because every file, even with normal text files, you have metadata that comes with it. This is my guess, but I don't know.
but wait, one thing in this kind of design questions, right? See, two things which they, what I understood is they're looking for is like it is make it more scalable, and at the same time it should be reusable, not constrained to one particular use case, correct? So I don't know whether thinking too much about the file type matters here, because it is like, see, the problem statement here is like upload file, correct? So it can be any file. So does the file format really matters here?
Yeah, I think it does, because it's very unlikely, for example, for YouTube to start supporting VHD files, right? So this is actually in real life and in system design, there is something that could be a difference. In system design interviews, I think it's good to ask the interviewer, how flexible do you want me to design? In real life,
Correct. That was my point. Yeah.
in real life, you almost always want to focus on the smallest thing possible first, because the design of each individual is actually quite different. Like if you're supporting a general purpose storage and upload, it's very different from supporting, say, pure text, because there's their website over there that just do copy paste, right? That's just support text, and they're the ones that support video. So you can do certain optimizations based on the different type of file, right? So, but that's not the only thing that you need to think about. So the question is, what else would you have to think about when you're designing this? So type of file, that's one. What else?
Yeah, I have this file white paper from Dropbox. I have saved it. I'll send this to you.
Yeah, thank you.
I think next question should be, are we considering any videos like any file size on an average? Let's say file size should not be more than 20 MB or 30 MB.
Definitely.
I'm sorry. Yeah, go ahead.
Some other stuff may not be that obvious, will be multi-region support. So do we need to design it so that, only say US West, people from US West can upload? That's the optimal, and we don't care about the other locations, or this is a global service. That has a big implication in terms of how you design your code, how do you replicate your backend. So multi-region support. What kind of basically SLAs you're guaranteeing, right? Is this service highly available? Can we miss files? Or is this file that say, I don't know, let's say bank transactions or something that we cannot miss at all? If there is a tolerance of things that we can miss, then the design could be also different.
And when we should acknowledge, like when we store only part of the file or the whole file?
Part of the file or the entire file?
No, the acknowledgement. When is it? Like after just receiving the first store request, we need to acknowledge that I received it and then send it. Is it an async acknowledgement or the sync acknowledgement?
Yeah, I mean, it could be for example, I think if I understand you correctly, let's say if we wanted to just upload a big chunk of file and we don't necessarily care too much if they go corrupt or not, like we can accept some of that. Let's say a video game, for example. And you could use a different protocol than TCP. The UDP protocol would allow you to stream much faster because it has much lower overhead, but it may have essentially lost frames.
Yeah.
That's acceptable, then that could be a choice. But if that's not acceptable, I have to choose like a TCP protocol. Not only that, I have to actually chunk each file and then be able to acknowledge that I have received the chunk. Yeah. That's another level of guarantee. So all this lays into your design. And this kind of just goes back to what I was saying. It's very important to understand the context, what you're designing. Even things like YouTube and Netflix, they all look the same, but in terms of the how they're used, scenarios are different, because Netflix, the content all curated by Netflix. So you will have much fewer rights. When they are uploading, they're uploading from their own data center, which has much higher bandwidth. Versus YouTube, where you can potentially even upload from your mobile phone, right? So that's actually also quite different in terms of how the contents are uploaded. And that changes your design quite dramatically. In fact, there is an article on Netflix, for example. This is not necessarily just video uploading, but Netflix has a microservice infrastructure. And then they would, let's say, have 50 different microservices. Initially, in order to ensure consistency, all their clients are using essentially the same client base, and they talk to 30, 50 different microservices. But if you look at availability, if each of those services is 99.9, maybe even 4 nines, 50 of those become 99.9 to the power of 5, which means you can never get to 99, which is quite low. So in their revision, what they did is they have a gateway in front of all these microservices, and then depending on the client, they may batch certain calls. Like if you have a lower bandwidth, they will batch the calls, and then they are going to fan out behind the gateway. So just depending on what service, what device you need to support, the design would be different.
Yeah. So Vijay, I have one question on cap theorem here. Can I ask you now?
Yeah.
So in some sources, I saw that we will have either consistency or availability. Partition tolerance, P is for partition network something. So that is always there.
Yeah, partition tolerance.
Partition tolerance is always there. Either cap or availability that we can have. So is that right?
You can have, well, it's a balance. The theorem says you cannot have all 3, but you can have 2 out of the 3.
So I can have consistency and availability. That's what you mean?
Yeah.
Okay. Partition.
I guess when you say have, it's not like a black and white switch, like just have it or not have it. It's really it's like a dial, right? So what that means is that if you want 100% availability, you have to give up on potentially partition tolerance, or the other what did I say, availability,
consistency,
or consistency, right? You have to potentially give up some of the aspect of that.
So if I say that my system is my system should be 100% available, for example bit URL or 10 URL,
Yep.
that should be 100% available. Does that mean it is okay if it is not consistent and partition tolerance? Because 100% we want availability. So that's what it goes. That's how it goes, or no?
Yeah, you have 100% of availability. You can still have 100% of one of the other, but you cannot have 100% of the other, all 3. Like you cannot have all 3.
Okay, understood now. So availability and consistency can be there together.
Yeah, we can probably touch that in the next question. Caching, I think we will probably talk about that.
Okay.
Yeah, we'll talk about a little bit more on that. How frequent? Yeah, frequent upload. Is it write heavy or read heavy? Your normal things like number of users, number of concurrent users. Those are all availability goes in here. And also your latency.
Latency, yeah. Did we write you the number of users, number of concurrent users?
Yeah. In a real if this were a real design question, I think when we gather this kind of stuff, we know roughly what the scenario is, and now you kind of have to make a choice between creating your own backend or using existing cloud provider backend, right?
Yeah.
That I would, if I were being interviewed, I would flip that question, saying we have 2 choices. I would prefer to use an existing cloud provider. But is that something that your company is comfortable with, for example, or is it something that I can use, or do you want me to also design the backend?
Okay.
if you were to design a backend, that's a lot more complicated. I have a document that I can share that's essentially Azure S3 equivalent, Azure Blob Storage implementation. So it involves in multiple layers. It has a very low level, which is called a stream layer. It doesn't care what file it is. It just treats file as streams. And one of the biggest thing about this is replication, right? It needs to be able to replicate file into different partitions. In the Azure case, you cannot lose files for customer. So that is important. But what do we sacrifice is potentially a little bit of consistency, because as it's being replicated across different data centers, you may not have all the file available at the same time. So, in real life, I don't know if this Dropbox thing, are they using any S3 backend, or are they creating, do they create their own storage?
Sure. Is it okay if we can consider that it is using S3 at the backend?
Yeah, in that case, you don't have to worry too much about the backend, and it actually solves your scalability question quite a bit, because in that sense, this is my past experience. What we did when we need to upload large file, what we do is we would send, first one, the client would request a place where they can start dumping the files to, right? So on the server side, we create a link. It can be authenticated, can be unauthenticated, doesn't matter. And then that link can go directly to the storage. So either S3 or Azure Connect. So then that way we are already diverting the traffic directly to S3, because all their backend have its own DNS. It doesn't need to even go to our server at all in that case. So all the traffic will go there, and then they have to, they are designed to implement and then scale. So this question then changes quite a bit. The question then becomes, when you're uploading file, how do you guarantee from the client side their experience, is met with all this SLAs and all this requirement? Yeah, I don't know. So far, do you think this is helpful, or like this? Could we?
It is helpful. It is helpful. Yeah.
Okay. Because I think the thing is, the question is not specific enough to be like go design the whole thing, but I think it has a lot of good things that we should think about, right?
Ganesh, do you have anything to add? I think this question is added by you, right?
No, this is me. No, I'm not.
Okay.
Did it answer your question?
Yeah, you answered my question. Let's say if we assume that the YouTube is what we are trying to solve.
Yep.
Right. So in that case, what would be the design choices I think we would like to take, given all these questions, right? So.
Yeah. So YouTube, if the YouTube is the thing, Google has its own storage. So most likely what you will see is you have some kind of a front end where you are taking the initial client request of upload. And that front end can generate a link. Sometimes it's called SaaS link, sometimes basically a direct link to a particular location, storage location. And then that location can be then sent to the client. In that case, client ahead of time is already telling the server, I'm about to upload this file of this size, of this type, of this video encoding. So the server knows when it will be done, so it can do the check. And then after that, the client will then just directly upload to that storage location. So it does not need to go to this front front server anymore. So the front server really is just responsible for ingesting the metadata, and then later on, all this information can be passed on to a service where they can ensure the consistency of the file and the file is not corrupted and stuff like that.
Vijay, I'm sorry, I couldn't understand. From client, where it is going? It is not going to server, you mean?
So, so what could be is your client, it can go to you know, web frontend.
Client web frontend.
Yeah, API front. I would just say API, and that would get you location. So, for example, this one could be, but
Okay.
can be a totally different location. Normally, let's say if you use S3, it will be some kind of like account name S3. Yeah, it's a whole bunch of like, you know, whole bunch of DNS. So this way you're not overloading your front end with the actual upload, because the actual upload needs to have a consistent session in kept. So that traffic needs to be separated from your intake. In real life, it's actually pretty, that's how it's done. Like data warehouse, right? If you have a data warehouse, normally you'll have a reception to say, okay, this is your manifest. This is the stock that the goods that you want to store. This is the manifest of it. I take it. Now you go to the docking, you know, I don't even know what they call it, but the docking place where that's when you actually unload. You're not going through my front door, because that's, you know, in terms of traffic, it's just going to overload the front end. Also, in this case, I'm making assumption that this is a big service. If you're saying this service only serves one client per day, it doesn't matter. You can just have everything in one. But I'm assuming if it's a higher traffic service, most likely you will have your upload location being a different location, where your front end ingests the metadata and provides the uploading.
Load location. Yeah.
Yeah. Does it make sense?
Yes.
Yeah.
Yes.
Yeah.
Okay.
And Vijay, can we say that once it gets upload location, it will just connect with it using TCP and transfer data, or I think it should be UDP and transfer data to S3 path.
It depends on the payload, but in most cases, I think TCP is probably more common for those type of files. UDP are normally used for gaming, like streaming games.
Okay. So back to Anil's question then. Okay, so if we are using TCP, then we can consider that client is getting response once file is uploaded completely.
Yeah, I mean, TCP actually would guarantee that each packet is checksummed and each packet is delivered. UDP does not guarantee that.
Yes.
But
Yes.
TCP doesn't guarantee the whole file because you're chunking the file. It does not guarantee the whole file is uploaded intact without corruption. So you will still have to check the integrity of the file after you receive all the pieces, because this is a higher level, right?
Yeah.
He's dealing with the very small packet.
Yes.
Another benefit of having this kind of approach is you could potentially avoid your kind of DDoS attack. Normally account names, you know, sometimes is good. This is DNS, right? So your DNS can serve as, in a way, a front gate if it's not very easily guessable, and you can also deactivate this independent of each other. So it's acting as sort of a defense mechanism for DDoS attacks. Okay.